Hello students, in this session we are going to study the deflection of cantilever beam with point load at the free end. Now we are going to use the moment area method and we have to find the deflection and slope of a cantilever beam with a point load at the free end. This is our aim, right? So you know that what is moment area method? That the slope between 2 points in a elastic curve, the curve after deformation, which is called elastic curve, is like this. The elastic curve of this is this, right? So the slope between 2 points will be the area of the bending moment diagram, right? So first we have to find out the area of this cantilever beam, bending moment diagram of this cantilever beam. What is the bending moment diagram? And then we have to find out the area if we want to find out the slope between 2 points. But our aim is to find out the maximum deflection and maximum slope. And you know that for cantilever beam, the maximum slope is at the free end, right? So this is our maximum slope. This is our maximum slope. If I see here, this is the maximum slope. If I take an angle here, I extend it here, I want to extend it here, I can make it here or here. This is the same thing. Suppose this is A, this is B. So this is theta B. Theta B. The deflection, the slope at point B, theta B, right? So the Mohr's theorem states that the slope between 2 points in elastic curve will be the area of the bending moment diagram. So what points should be chosen? So that we can find out theta B, which is theta max. As we know that theta B is theta max, and our aim is to find out first this theta max, and we want to use the Mohr's first theorem for this beam, right? So I want to find out theta B. I should choose a point where theta is 0 so that I can find out the difference between 2 points by the area of the bending moment diagram. So choose any point where the slope is 0 so that we can find out the difference between 2 points as theta B minus theta A. So suppose we know that the slope between 2 points, this slope at this point, A point, is 0. You know, already we know that the slope at point A is 0 for a fixed point, fixed end. Slope is always 0. So this is known to us that theta A is 0, right? So if I take this as a reference point, and then we can take the difference between these 2 points. So if I take the theta B minus theta A, and this is the area of the bending moment diagram divided by EI according to the Mohr's first theorem, area between theta B and theta A. And we know that theta A is 0. Theta A is 0 because slope at the fixed end is 0. So theta A is 0. So ultimately we will get the theta B, which is equal to area between B and A, divided by EI, right? So this is how we can find out the slope, right? So first we should know the area of the bending moment diagram. So first draw the bending moment diagram. So if we draw the bending moment diagram for this beam, let us draw the bending moment diagram for this beam. So this is the B point, this is B dash, right? And this is theta B, right? So bending moment diagram, how to draw the bending moment diagram for this beam? Now we know for finding the bending moment diagram, we have to take a section X at a distance of small x from the free end, and the moment of this mx will be equal to w multiplied by x. So this will be w multiplied by x. This is the bending moment. This is the bending moment, right? And this is a linear variation in negative sign. So we can take a line here, right? This is our AB beam, and it is the bending moment is increasing in negative direction with linear variation x. As we move on, it goes on increasing, so we will get this type of curve, right? Already you can see here in the shear force bending moment diagram chapter, this is a linear variation, right? this is a linear variation, that mx equal to wx, right, in negative direction, and this is negative. And what is bending moment at a? At a, this is w multiplied by l. So at b, this will be where at b, at point b, the x is 0. You can see here at b x equal to 0, so this will be equal to 0. And at a, where x will be l, this will be equal to minus wl, so this will be wl, where l is the length of the beam, total length of the beam, right? So this is the bending moment diagram, right? So what is the area? This is a triangle, this is the triangle. So what is the area of the triangle? You know, half into base into height. So area of this triangle from A to B, because this area is from B to A, between which we want to find out the slope. So this area is between A to B. Here A is the area of bending moment diagram between A and B. Between A and B, this is area. And from this triangle, the area is half multiplied by base, this multiplied by height, WL. So this area will be equal to half multiplied by base, which is L, multiplied by height, which is WL. So this will be equal to half WL square. So this is the area, right? So theta B will be equal to theta B, which is theta max, now will be come out to be WL square by 2EI, WL square upon 2EI. So this is the slope, this is the maximum slope at point B, right? This was our aim, to find out the maximum slope, and this come out to be WL square by 2EI using the Mohr's theorem. So Mohr's theorem says that the difference of slope between 2 points is the area of the bending moment diagram between these 2 points. So area of the bending moment diagram between 2 points, and what 2 points we have chosen? One point is where we want to find out the maximum slope, so theta B is the point where the maximum slope is there, so theta B. Another point we have chosen where the slope is 0. At fixed point we know the slope is 0, so we have chosen 2 points, theta B and theta A. So theta B minus theta A, the difference between 2 points will be the area divided by EI, area between B and A, this is the area between A and B, and divided by EI, this is the Mohr's first theorem. So this is the Mohr's first theorem, right? So I am writing here, this is the Mohr's first theorem, right? Mohr's first theorem, right? Now using this Mohr's first theorem, we have find out this concept came from the Mohr's first theorem, right? We should remember this Mohr's first theorem, that the difference of slope between 2 points is the area between the area of bending moment diagram divided by EI. So A is the area of the bending moment diagram between A and B. So now area is the half base into height. We have drawn the bending moment diagram between A and B and find out the area, right? So this is the concept, right? Now we want to find out the deflection. How to find out the deflection? Maximum deflection. How to find out the maximum deflection? How to find out the maximum deflection now? Maximum deflection, right? So finding the maximum deflection. So how to find out the maximum deflection? For maximum deflection, we should choose a point where the deflection is maximum. You know that the tangent, what is the Mohr's second theorem? Mohr's second theorem, what is the Mohr's second theorem? That tangent between 2 points on a vertical line, on a given vertical line, gives the, will be equal to the area, the moment of the area of the bending moment diagram, right, divided by EI, right? So what 2 points should be chosen? We should choose the reference line like this. I have chosen reference line here. This is the reference line. I have chosen this as a reference line. This is the reference line, right? Why I have chosen this reference line? Because the tangent of the at this point, you can see here the tangent at this point, tangent at a point will be lying on this point, right? So this is the tangent of A, this is the tangent of A, right? Tangent, because it is a straight line, because the slope at this point is 0, so this is the tangent of A, right? And intersecting this reference line. Now the maximum slope is B, so the second point is on this point B dash, this, the tangent of this, this point is tangent of B, this is the tangent of B, and the tangent of 2 points will give the deflection, so and we know the maximum deflection is at this point, so this is the y max. So by taking the tangent at A and B, this is the y max. So we have chosen 2 points, A point and B point, such that the tangent at A point and tangent at B point, the difference of this point on this vertical line will give the maximum deflection, right? Because our aim is to find out the maximum deflection. So now you should know that why we have done this thing. We have taken reference line here which is passing through B, right? One point is this line, because the tangent at this line will be passing through this reference line. Second is B, the tangent of B point is passing through this point which is B dash, right? And this distance between two tangents on a vertical line, the distance of two tangents on the vertical line will give the deflection. So by this we can find out the maximum deflection. Now what is the theorem? That you have to find out first the CG, center of gravity of this curve, area of the Van Neumann diagram. This is the area of Van Neumann diagram. So what is the center of gravity of this area? So center of gravity lies at 2/3 from the vertex and 1/3 from the this base, right? So this distance is 2/3. This distance is 2/3 of L, 2/3 of L, right? So this is 2/3, and the theorem says that if you find out deflection at 2 points on a reference line, then we have to take moment of the area of the Van Neumann diagram, moment of area of Van Neumann diagram from this line, this point, centroid, to the this point, right? This and the reference line, right? So what is moment? The area of this is half into base into height, and area of this moment of this area will be, the centroid of this will be passing through this line. So we have to take the moment of the area, then we have to do the product of the area and the distance, right? So area is basically half into base into height, WL. So this is WL square by 2, and moment of this, and this area will be passing through this point. This area is basically passing through this point, this area. WL square by 2 will be passing through this point, WL square by 2, and we have to take the moment of this area on the reference line, about the reference line, right? So moment of this area will be, suppose this point, this is called x bar. I am saying this as a x bar, right? So moment of area will be this area, the total area multiplied by x bar. So moment of this area will be moment of area about reference line, So this will be equal to, what will be the moment of area about the reference line? That will be equal to ax bar. It means ax bar. So that should be equal to WL square by 2, the area multiplied by the distance. This is 2/3 of L. 2/3 of L. So this will come out to be 1/3 of WL cube. So this is the moment of area, WL cube by 3, right? So now what to find out? The YB, the distance of this Y max. So Y max will be equal to, what will be the Y max? The moment of this area about line BB dash, about reference line BB dash, right? So this will be moment of area about BB dash. So this Y max will come out to be, equal to AX bar upon EI divided by EI. Is also here, EI. So AX bar by EI, and AX bar is WL cube by 3. So finally we will get Ymax as WL cube by 3EI. So this is our Ymax, right? So now you understand why we have done this thing, that we have taken a reference line here. This reference line is chosen BB dash. This reference line is chosen because the Ymax is going to lie on this point, because for cantilever beam we know that the maximum deflection is at the free end. So we have to choose 2 points, because the tangent is going to pass from this vertical line. So one tangent should be passing through this point from B point, another tangent should pass through BB dash, so that the distance between two tangents will be crossing this line gives the maximum deflection, right? So one point is chosen here because the tangent of this point is passing through this point, B point, and another point is chosen here. The tangent of this point is passing through this point, right? And the difference between these two tangents on this reference line gives the maximum deflection, right? So what is the theorem? That the area between, first you take the area between A and B. So area between A and B is the total area which is passing through the centroid, WL square by 2, and take the moment of this area about this reference line. So we have taken the moment of this area. So this area is at a distance of 2/3 of L from the B reference line. So this will be, moment of this area will be AX bar, which is the area WL square by 2 multiplied by the distance, perpendicular distance. So this is the moment of the area, right, between A and B. So here, maximum Ymax can be obtained by now AX bar by EI. So that will be equal to AX bar is WL cube by 3 divided by EI. So this is how we can find out maximum deflection and maximum slope for a cantilever beam loaded with a point load.